Good job finding this video for today. Before we go into our notes for today, we're going to very quickly go over the warm-up because I want to make sure you have the answer. So turn to your warm-up and make sure that you have the correct answer. So the mass of the paintbrush is 90 grams. What is the density of the paintbrush? I wanted you to justify your answer. Well, yesterday we learned that density equals mass divided by volume. So if I know the mass of the paintbrush is 90 grams, I can at least plug that in for the formula. Well, now I need to know the volume of the paintbrush. Since this is an irregular shape, I cannot use the length times width times height method, so we're using the displacement method to calculate the volume of the paintbrush. When the paintbrush is put into a graduated cylinder, it displaces 30 milliliters of water. So I know that I can set up my problem like this. The mass of the paintbrush is 90 grams, they told me in the problem, and the volume of the paintbrush is 30 centimeters cubed because it displaced 30 milliliters of water. When I divide both of these, I calculate that the density of the paintbrush is 3 grams per cubic centimeters. Grams per cubic centimeters is the unit for density. You should have obtained that answer by dividing the mass of the paintbrush divided by the volume of the paintbrush. So now turn to the IP page where you're going to be taking your notes. If you don't know what page it's on, please refer to your instructions on your paper today. But pause this video so that you can set up your notes with the title of the topic, density, and the essential question. How is density measured and how does it affect floating and sinking? Before we get into the notes, I want to show you a quick clip of the brain pop just to review something you've already seen.
Density. Density measures how heavy something is for its size. Are its atoms packed close together or far apart? We can calculate density by dividing an object's mass by its volume. Let's see, the mass was 250 grams, and the volume was 1,000 cubic centimeters. 250 over 1,000 is 0.25. So the density of this cube is 0.25 grams per cubic centimeter. Pretty impressive, huh?
So that was just a quick review of density. Here's what you need to get into your notes today. Density describes how tightly packed the matter is inside an object. So both of those cubes from the brain pop had the same volume, but because the matter in this cube was less packed together and the matter in this cube is more packed together, then they have different densities. Because density describes how much stuff is inside an object compared to its size. And here's how density is measured. Density is measured in units of mass per unit of volume. And some people actually define density as this: how much stuff is inside the mass per how big it is, what its volume is. We calculate density or measure density using this formula that density is mass divided by volume. And because it's these three variables, we can use what's called the DMV triangle in order to calculate density or mass or volume. So please write down this DMV triangle. Please include what would be the units for mass, grams or kilograms. The units for volume would be milliliters if it's a liquid or cubic centimeters if it's a solid. And therefore, the density units for an object would be grams per milliliter if it's a liquid or grams per cubic centimeter if the object is a solid. So here's how you would use density in order to determine if an object will float. There's actually two reasons why an object will float. A couple weeks ago we talked about an object floating because of buoyant force. Well, now we have to take into the account the density of an object, because there's actually two reasons why an object will float and have positive buoyancy. An object will float if the density of the object is less than the density of the fluid that it's in. For example, this rubber ball floats on the surface of the water because it has a density of 0.75 grams per cubic centimeter, and the water has a density of 1 gram per milliliter. Remember, that's a liquid, so the unit of density is different. So since the rubber ball has a density less than water, then it floats. But the second reason why an object will float is if the weight due to gravity and the buoyant force are equal. We've learned this before, that an object will have a positive buoyancy if the forces are balanced. the weight and the buoyant force are equal. So there's actually two reasons why an object floats. It's if the density is less than the density of the fluid, and if the forces on the object are balanced. These two things are happening at the same time. Take a minute to draw the picture. Make sure you label this floating object as having a positive buoyancy. So an object will sink if two things are happening. An object will sink if the density of the object is greater than the density of the liquid. For example, this steel ball has a density of 5.5 grams per cubic centimeter, while the water has a density of 1. The density of water is always 1. So since the steel ball has a density greater than water, it sinks, and we say that it has a negative buoyancy. But the second reason why an object sinks is if the weight is greater than the buoyant force. We've learned this before. So two factors are coming into play, which is when an object sinks and has what's called negative buoyancy. If the density is greater than the density of the fluid, and if the weight due to gravity is greater than the buoyant force. Draw this picture, label this, and make sure that you write this as negative buoyancy. But there is a case when an object will neither float nor sink. For example, this fish that would just like hang out in the center of the water. It's not floating up to the top, it's not sinking down to the bottom, in which case we would say that the fish has a neutral buoyancy. An object will have a neutral buoyancy if the density is the same as the density of the fluid. Like if the fish has a density of 1 and the density of the water is also 1. And if the forces are balanced, the weight of the fish is equal to the buoyant force, in which case we call this neutral buoyancy. Astronauts do this all the time. When they are training in what's called the neutral buoyancy lab, they create them having themselves have a neutral buoyancy so they can get what it feels like to be in outer space. They neither float nor sink because they have a density that is the same as the fluid that they are in. So here's your next job. You need to write 3 sentences in order to answer the essential question. I want you to highlight and number your periods. I also want you to go back through your notes and make sure that you have a question for each section of the notes. And here's your output page when you're done. Your output page today is quadrants. Your 4 quadrants will be titled mass, volume of a regular solid, volume of an irregular solid, and density. I want pictures, not about what these definitions are, but how they are measured. How do we measure mass? How do we measure volume of a regular solid, volume of an irregular solid, and how do we measure the density of an object? Let me know if you have any questions. Otherwise, pause this, go back, whatever you need to in order to get your IP notes done and your OP assignment completed. Have a nice day.